draft physics video presentation. So we're going to do the more double slit stuff. Another video by somebody who's got 50,000 subscribers. Not insignificant. The view numbers aren't that good, but whatever. Still thousands, and it's just junk science. So it's sold as whatever, secrets of the universe. The secrets of the universe. That's what he calls himself. Anyway, and it's just so bad. It's the same argument I've been making. I mean, all of this physics. I mean, physics is, the science. And it should be showing an example for all of science in terms of how you do science and what the whole process is and how important it is not to be fooled and not to jump the evidence and to be disciplined and careful and all of those things, and all of that goes, and it's sort of, there are, doctors and nurses who seem really clueless about simple things like washing their hands. Like they never heard of bacteria. And you just kind of wonder, like, how the hell they get through medical school and they haven't heard about this notion that, this is dangerous, this infecting thing. And they just don't have a clue. Not like they should be hyper paranoid, but I mean, it's like they're completely unaware that there's an issue, and you're just like, how, haven't they heard the whole Pasteur story and, the whole, like, most women who died in childbirth died by stupid infections. I mean, they don't know any of that. And you're saying, okay, these guys have physics degrees, and okay, they spent a lot of time learning math, but they really didn't learn about what science is and how to investigate and what a real experiment is versus an imagined experiment, or what you think happened, or what somebody said happened but didn't, not getting any evidence. And clearly that's all it is. So they're taught badly, and then they teach badly, and so on and so on. And they create a whole science based on a bunch of mystical and mythical stories. And none of it's grounded in anything real. I mean, I could point again to even like the Einstein statements, okay? I mean, that they never proved, like the fact that light is bent by gravity. I mean, it's such an elemental thing, and they've never gone out and said, well, let's really prove it for a change. Instead of just saying it, let's prove it. And then the other part of relativity is this, this whole little change in Mercury's orbit. And, Einstein provides a whole giant pile of mathematics to give you a little tiny change in gravity for objects that are close. So it's a real convoluted, like, let's multiply the top by 2 and let's divide the bottom by an extra, instead of r squared, it'll be r cubed, and then we'll divide the speed of light into it. And so we're creating a little bit of noise that's really just saying, whatever I analyze, if it's close, I change it a lot. If it's far, I change it a little. And that's all it's really saying. So it's like perfect. If all you have to do is have a change that's only affecting Mercury, then you're safe. You can just contrive anything. And like I said, all I have to say is the sun precesses. And as long as I make the sun precess just a little bit, it'll only affect Mercury, because only Mercury will be close enough to feel to experience the change. And all the other planets are safe. None of their orbits change enough for it to make any difference. And so I have a perfect equation in the sense that it works. But it won't work if I have something between Mercury and Venus. Then all of a sudden it might not work anymore, if there's some other test. And they have actually come up with competing theories of gravity to explain why stuff is moving faster on the outside of galaxies that does exactly the same thing. It creates an equation where it only creates a difference when it's far away. And when it's close, there's no difference. So it's exactly the inverse. And it's just a gimmick. It's clearly you can just explain it as it's just a gimmick. I can just contrive any mechanism. I don't have to have a reason to do it. I mean, it doesn't have to be a rational equation at all. It doesn't have to have any meaningful variables in it. All it has to do is create differences in certain locations and no difference in other locations. And like I said, you just do that by making denominators bigger, you know, as distance increases, and problem solved. So I mean, these are superficial mistakes. These are, I mean, they're in a sense, you know, trivial in the sense that they're just they're so obvious that this isn't very credible. That when you have something that fits, it's only fitting for a stupid reason. It's like you could design a shirt that you could wear as pants. You know, you could do these things, and it's possible. And the fact that it's possible doesn't mean it's reasonable. But you know, it's no point in talking to you people because you're all devotees of a religion. So there's just, you know, you don't want to hear the truth, that the whole thing is rather incredible. And it's going to be, you know, like I said, eventually human beings they progress, you know, in terms of the knowledge base that's gained, and finally they'll see an error, and not necessarily fix it. They'll just say, well, there's an error there, you know, like plus and minus being wrongly assigned. It's rather critical that you fix that kind of stuff, rather than just create a rotten legacy of misinformation that's right overt, where you know, labeled up, down, and vice versa. But anyway, I mean, like I said, what's the point of the conversation? Because the fans just don't want to hear how their team isn't the best. You know, they just don't want to hear it. All right, so this is just another example of just a pile of garbage in terms of an explanation of physics. It's the evidence doesn't exist that's cited. There's no good reason to believe, and it's just being sold like it's just propaganda, just spilled out propaganda. It just really has nothing to do with science, discipline, getting it right, none of that stuff. It's just hyperbole. Alright, so I guess I play the video now, right? I guess so. Okay, hit the button.
When both the slits S1 and S2 are open, on the screen, we observe a very strange pattern of light as shown in this image.
Right, so we know this is the double slit. We know this isn't the real double slit pattern. It never looks like this unless you have a slit that's smaller than a, well, yeah, even a slit smaller than a wavelength won't produce this. It has to, this number of bars taken across a whole 90 degrees would probably number in the hundreds. So obviously the slit can't be that narrow. Just obviously. Well, the middle impediment is in this case creating the width of the bars, because what you're doing is making the slits so small that their contribution from the outside dimension is the same size as the inside dimension. But anyway, it's obviously, anybody who knows anything about these slit experiments knows that you can manipulate them by manipulating how big and how wide the slits are. Makes a huge difference in what pattern you see, and that the patterns are different. So I shouldn't have to make this argument that this is not traditional double slit. This only happens, it only looks like this when you make the slits smaller than the wavelength of the light.
Alternate bright and dark fringes of light. This pattern is known as the interference pattern. I've also plotted the curve of intensity of the screen on the board. You see there is maxima and minima of intensity at regular intervals.
And of course that doesn't happen. The maxima and the minima are diminishing in strength as you go further out to the left and to the right. There are fewer and fewer photons. So, just a fact. It is not some consistent pattern that just consistently goes.
So, this pattern is known as the interference pattern we see when both the slits are open.
Right, it's known as something it isn't because they've already projected the conclusion. You know, they just say it. But the facts are there's every good reason to think it's just the Reconstruction pattern. There's just as good reason to call it the Reconstruction pattern. You broke photons by forcing them through an obstacle course, and at the end you had pieces of photon, and you could remake some photons out of the pieces.
What happens when I close one of the slits? That is, suppose I close S2 and keep S1 open, so light is only passing through S1. This pattern mysteriously disappears. We no longer see alternate bright and dark.
Right. Now this again is only if the slit width is smaller than the wavelength of light, which is really small. We're talking about 1,000th of a millimeter to really do that. Really, really insanely small slit. And then the light scatters in all directions because there's not enough difference. There's no wavelengths inside, so you can't make two different points. The two vectors are so the same that there's constructive interference, so to speak. There's remaking of the photons at every location because there isn't enough length difference between the two paths. So you can't change the phase. You can't have a phase difference if the 2 points are less than a wavelength close to each other. You can't create a phase difference between the two vectors. You can't draw two lines that have a full wavelength of difference because you don't have enough distance between the 2 point sources. So yes, you defeat the entire concept of constructive and destructive by making the slits so small that there can't be either one.
Fringes. All we see is a single maxima in front of the slit that is open.
So again, that doesn't happen in any reasonable slit width. So if the slit width is anything more than a wavelength, you won't get a single hump. You'll get 2 or 3 or 4. You'll get a pattern, and that single slit proves this. So I mean, there's just no reason for a rational person to say, well, that's a good way to describe it. The light just clumps, when we know the single slit experiment exists and it doesn't clump. You can have 50 or 70 bars of light with a single slit. So a reasonable opening creates lots of pattern.
In our case, we had S1 open, S2 was closed, hence we just see a single maximum of intensity of light in front of the slit that is open.
So now he says the same thing that's been said before. I mean, it's this simple error. I mean, you know, I'll go through it one more time just because it's such a silly error that it shouldn't be made by anyone. Nobody should be making this mistake. All right. So we'll have to adjust the camera, of course, because somehow everything gets screwed up. How come that isn't in the right location? Must be some kind of glitch caused by some sort of glitch-causing device. Okay, that's the background. I need this thing to move, whatever the hell this is. Where is this? There it is. Oh, it's still not big enough. Alright, well, I'm not going to worry about it. At this moment, it's not that critical. I could fix it, right? If I double-click this, I should be able to make this bigger. Gave me the wrong one again. Come on, make the right one movable. Sorry, it didn't make it any bigger. That is strange. So this one's outside of the framing box? Well, anyway, alright, we'll just pretend. No, that was the wrong one again. You know, it made the Firefox bigger, right? Yeah, it did. Stupid bastards. Alright, I'll get this done. No, yeah, it's little stuff, but I mean, I have to, it takes time to get all this stuff figured out. See, if I click it, it doesn't, there it is. It's huge. Enormous. Alright, so I have to make that bigger. There, now it fills the box. Alright, so that's better, right? Right. Alright, so, slit. So, as pointed out, they're making this slit width so small that there's no distinction between this distance and this distance. And that's the only way you can make the pattern look uninteresting. So you have to make this total distance so much a tiny increase over this distance, and therefore the two different point sources, these 2 point sources and these 2 point sources, will essentially be doing the same thing, and you won't be able to see the difference. Alright, but this point is that this is a tiny, the total experiment is like 1 millimeter, okay? And when you project it, that part of the experiment doesn't get any bigger. So light that goes straight through and light that goes straight through without diffracting, without being spread by scatter at the surfaces, it's only 1 millimeter here. Okay, it doesn't spread. So there's no this slit clumped over here and this slit makes a clump over here. That doesn't happen. You're looking at these clumps on the board and they might be 5 inches across. You're not going to see this 1 extra millimeter. The two are going to be almost right on the same spot. So you'd almost never see any difference between them at all. So, this is just more of the just misinformation, more nonsense that this is, that there's a logic to this experiment when they don't have any logic. It doesn't make any sense. And they can't even get something this simple right. So I'm just saying there's good reason to doubt because they can't get these simple details right. Alright, back to the videotape.
Thing happens when we close S1 and keep S2 open. That single maxima shift towards S2.
So he says shift towards S2. So you'd be somehow like you'd see that tiny difference. You wouldn't really see it. It's so tiny. The two clump. When you cover one slit, there'd be a clump. You cover the other slit, the clump would be essentially in the same exact space.
So we have got a couple of observations. That is, when both the slits are open, we see an interference pattern. That is, alternate dark and bright fringes of light on the screen.
Right, and again, you're only that, in this case, you're seeing essentially the width of the impediment. That's deciding. And because you're adding so little extra distance to the other point sources, they become irrelevant. They don't have any effect. The vectors from the new point sources are exactly almost the same length as the vectors from the original 2 point sources. So you've kind of just redundantly added point sources that are exactly the same vectors, and therefore you can't have any adding or subtracting.
When we close one of the slits, we no longer see that pattern. We just see a single maxima of light. Okay, so now we have...
So now we know that that isn't true. So if the slit width is anything more than 1 millimeter, we see a pattern. So with a single slit. And realistically, the slits are going to be a lot of millimeters. They're not, a lot of wavelengths. So this whole conversation is moot in that sense. And 99% of the ways you can do the experiment won't work with his logic. Only 1% of the ways you can do the experiment work. So that's that's clearly shenanigans.
Got a couple of observations. What is the next step? The next step is to see which theory of light better explains the results of Young's double-slit experiment. Is it Newton's particle theory or is it Huygens wave model?
So again, it's these two stupid choices, and when the real choice, what a particle theory would have to do is duplicate frequency. So again, they're just pretending that somehow the particle is the frequency. That somehow you measure the distance from this side of the particle to this side, and that's somehow its frequency. When no, frequency is the distance between particles. It's the period of time between events. Photons are events. They happen in a sequence. That's the frequency. The frequency is telling you it's an event that has a period of time that it consumes for the event to take place. There's step 1, step 2, step 3. It could be 10 steps, it could be 3 steps, it could be 2 steps. The point is it's the time between the events. So they don't even consider that as a theory. It's not possible that it could be bullets fired from a gun, for example, something obvious. Could be cannonballs fired from a cannon. That theory of particle they won't even consider. And then they'll have a contest. So that's called straw manning. Now, scientists shouldn't be making up straw man arguments to make their point, right? They shouldn't be sitting there pretending they can't figure out, oh, particle could mean shot out of a cannon, and shot out of a cannon every 3 seconds. That's what particle could mean. And just, but they'll draw their waves. When they draw waves, they don't draw one wavefront and say, there, waves. No. They draw multiple wave lines. indicating clearly that they understand, oh, to understand frequency, you really have to see more than one wave, don't you? Yeah. So it's so obviously a distortion, so obviously presenting the evidence in a certain perverse way to make it look the way they want it to look.
Let us start with the one that was more famous back then, Newton's particle theory of.
So again, Newton didn't have an elaborate particle theory. He just had the idea that, hey, it looks like it's stuff traveling in straight lines like the way you throw a rock. And he didn't know a whole bunch about frequency and all that kind of stuff, okay? They didn't have a way to measure all that. So from his perspective, he's just saying, yeah, there's blue rocks, red rocks, yellow rocks.
Wild thing.
Thinker.
You owe us $48.50. Wild thing.
If you ride, you get it. Geico Motorcycle.
For that, consider the point P
I don't think anybody got that. What the hell was that about?
on the screen, okay? When both the slits are open, we see that we have a dark fringe on P, that is, no particles of light are reaching point P on the screen. But when I close one of the slits, that is, when S2 is closed and light is only passing through S1, I see that a good number of particles of light are reaching the point P. No,
So, yeah, because you drew it, that's the only reason, right? So there's no rational argument here. They've never done this experiment successfully. It hasn't ever happened. So, this is just citing something that just plainly isn't true. There's no experimental evidence. I've searched, and it doesn't exist. The only one that does exist is one brought up by a troll of a Christian physicist. Okay, and he didn't do the experiment. He did it obviously with chicanery, where he did a 3-minute video where he just told us what was happening, and as I pointed out, he clearly was using the chicanery of an error, an algorithm that that made it, when you added more photons, it thought they were coming too quickly, so it didn't count them because they came in the same sequence of time. And so obviously when you added more photons, it would look like less photons because now they're being canceled. So, I mean, clearly really bad science. I mean, it's basically a fraud, There's no other word for it. I mean, it's so manipulated. It's like the Veritasium thing. He could figure out that, well, obviously my detector sucks if it's getting 7 error photons a second, and so I got to use a better detector. Our eyeballs are better than that. Anything's better than that. So yeah, use your own eyeballs or something. Use a magnifying glass in your own eyes, because at least it won't get 7 errors a second. All right, wait. So this is the old bullshit story. Okay, you have the 2-slit experiment, and we have this magical way of just opening and closing the slits, which isn't that easy anyway. But anyway, let's just say you had this magic capacity to do that, and so you could just open one and then open the other. And so the argument is somewhere they did this experiment, and when the both slits are open, let's just say there's light here at this point. Okay, and then when they close one of the slits, this piece of light disappears and it goes black. Doesn't happen. It's not what happens in the experiment. So understand, when you do the experiment, the double slit, you have a light source, and obviously most of the brightest light is being blocked by the impediment. So you're not sending any photons. The number of photons that get through unmolested is smaller. All right, because and you have 2 smaller openings rather than one big opening. If you had one big opening, you'd have higher percentage of the light would go straight through, right? You could understand if I had one big opening the size of both of these added up, obviously there's lots more places in here for light to get through. So when I make 2 smaller openings, I reduce the number of photons that can successfully get through unmolested, because I've created 4 surfaces instead of 2 surfaces. That's the obvious point to make, right? When I have 2 slits instead of just one opening, the biggest difference is I have twice as much surface for the photon to be next to. But anyway, So the point is that what's really happening is that there are in fact 4 point sources in the experiment, and what you're doing by adding a second slit is quadrupling how many you're doubling the sources, which means you're going to quadruple your capacity to remake a photon, because you have to think of each point source as being combined with this one plus this one plus this one. So as I add sources, I multiply the ability to remake a photon. So what really happens at this location is that it was a dull photon that you were getting with both slits open. And it was, when one slit is open, the photon is dull, and that's why you're not seeing it. So with both slits open, the brights are 4 times their normal brightness. They're 4 times as bright as they would be if you had only one slit open. So you're increasing how bright it is, okay, by 4 times. And so when you close one of the slits, the decrease from 4 to 1, x, means it looks like it went dark, but it never went dark. It's just that it's 4 times brighter when you have both slits open. So it never went dark. The photons never got canceled out. You're just getting a 1x view of the photons with one slit, and with both slits you're getting a 4x view. And that's all. That's why it looks brighter, but it never goes dark. The photons that go there with one slit are there, they're just dimmer than the photons with 2 slits. If you open both slits, more body parts, more pieces, more capacity to reconstruct a photon, because now you have added these 2 extra sources, and therefore multiplied how many successful photons you can remake. So nothing ever goes from being, hey, light was going there with this slit open, light was going to this location, and when I opened the second slit it went dark. It never went dark. The bright spots got 4 times brighter. Alright. So they have no experiment for this garbage. And it's just garbage. They're claiming that you add more light and photons, places where there was light went dark. Nothing ever goes darker. They have no experimental evidence indicating that ever happened.
Why would the particles of light be so shy to reach P when both the slits are open, and they do reach P in a good number when one of them is closed?
So again, it didn't happen. So this question is moot. And again, it's just for propaganda purposes. Whoa, how mysterious, how strange. Whoa, isn't that crazy and bizarre? We must come up with a bizarre explanation, because that's just bizarre and crazy. I turn on a second flashlight, and the first flashlight's beam goes away. But again, it doesn't happen. When I add the second flashlight, I got 4 times as much light, is kind of the argument. Obviously with flashlights it doesn't work that way because they're not broken photons. But when you're sending broken bits, you can reconstruct more whole bits if you add more sources.
So Newton could not explain the interference pattern. I'll give you another example.
So Newton couldn't. Well, this wasn't even part of any of the Newton's analysis, was any of this disappearing light theory. So this had nothing to do with Newton and what he could explain.
Suppose I draw
Look, subscribe for more.
a couple of slits on the board, like this. I name this S1 and this as S2. Your job is to throw indestructible stones on these slits. Only 3 things can happen. Either...
So again, why do they have to be indestructible stones? Why are you assuming that photons aren't composite objects and that they're easy to break? They're big, they got gigantic polarization. So it's obviously, whatever they are, it's spread over a large area in one dimension. So why couldn't I break it? And why can't I just knock it out of phase? Why can't I, if it's got 5 little elements, 5 bullets, just knock one of the bullets out of proper phase, proper order, and all of a sudden I've broken the frequency, and now you're not going to know it's a photon, because your detection is completely dependent on having a consistent frequency. So anyway, that theory perfectly works.
the stones will pass through S1, or they will pass through S2, or they won't pass at all. So
Right, so we don't have any logic where we say, well, what if they went next to the surface versus going right through the middle? That's a completely different environment, right? I mean, we know the surface is made out of electrons. We know that it's charged. We know that a photon traveling through that area, photons often interact with electrons. And when they interact with electrons, they scatter, they change their direction. So that could be a clear and easy explanation for why there's a bunch of changes in the direction of the photons, is because obviously there's electrons on the surface and they hit them. There. Perfectly valid theory. Never considered. They just throw it out. No, we have two choices. It goes through or it doesn't go through. That's it. Slit surfaces don't matter. It's not relevant to these people. They're physicists and they don't care about the surfaces.
behind the slits, your stones should be collected like this. Behind the slit S1, these are the stones that will be collected. And behind slit S2, like this.
Right, but we know that doesn't happen, so what's the point of this, right? We know that doesn't happen. A single slit does create scattered photons. It does create photons that get diverted. So why are we pretending it doesn't happen? Oh, that's right, because it's part of the narrative. It's part of the magical story. But it's not part of any kind of rational, fair, correct analysis of the phenomenon. So they're not after the truth. They're just reciting their biblical stories.
Now, if this is true for the indestructible stones that you're throwing at the slits, this should also be true for the particles of light that are reaching the slits and are collecting on the screen.
So again, this logic is just idiotic. It's not anywhere, it's not fair to what the possible arguments for how particles could be manifest. It doesn't deal with phase or frequency or the fact that, like I said, that you can know that photons have to have more than one component to them, just as your waves have more than one wave in them.
Newton could not explain the interference pattern. He could not explain the alternate dark and bright fringes on the screen mathematically. If I1 is the intensity...
No, mathematically he could. They could all draw these vectors. But again, knowing that light had a frequency and that light was at a phase, that was asking Newton to know a lot that he couldn't know.
Intensity of light that is reaching because of slit S1 when S1 is open, and I2 is the intensity of light through S2. Then the sum of these intensities is the resultant intensity, that is I, that is reaching the screen, should be I1 plus I2. This is what Newton...
Yeah, that would be the logic if you weren't putting pieces together. So the idea is all you take them is say, look, and the polarizing film kind of proves the point, and you still haven't gotten that one right. You have two pieces of film, you have the filters in inverse positions, you get 0 photons. I put a third film in, and now I get photons back. Well, obviously the two films didn't destroy anything because you're fixing it by just putting one in between the two filters. The first photons couldn't have been destroyed, you're just fixing them, obviously. So you're fixing some of the ones broken by the first film by putting them back in phase by adding another piece of film. So it wasn't that the photons were destroyed, it wasn't that they destructively interfered with anything. They weren't annihilated in any way. No, the phase was just broken, and you fixed the phase, and the photons fixed again. So obviously that's the answer. So the I1, I2 argument, again, this is where I just pointed out why when you add more sources of parts, you can put more things together. So if I mix the parts to make a car, and I put them in 4 different sources, the more sources I have, I double the capacity to remake a car by increasing the source. So all I have to do is add another source of parts, and I'll not just add that number of added parts. It's that I've increased the likelihood that I have the A, B, C, D parts. I have all 4 parts.
Particle theory of light says. Now let's go to the less popular theory of light in the 17th century, that is Huygens wave model. Classically, if you want to describe a particle, you just need one parameter, its position. Once you have the position, you can derive its velocity, acceleration, momentum, energy, etc.
Right, so, and they've turned that into a frequency. So they're just saying that the frequency is the object. When I would argue all of the rational analogies The object isn't the frequency. The frequency is how often the object shows up. I mean, the frequency of army ants coming for you. I mean, every analogy you can use, even wave theory, again, is a theory of frequency, and the frequency is built into how often the event of wave happens. That's the frequency. How often does it happen, and how, and what time scales it happens. So when you give the object, and you just say the object is 6 waves, that's the irrational, unanalogistic, not connected to anything we actually see in the universe theory of a wave or a frequency. Frequencies always have components, and the components have a period. Giving a, like I said, giving a Volkswagen a frequency is silly, or a Maserati. Giving a human being a frequency is silly.
If you want to describe a wave, you need 2 parameters, its amplitude and its phase. So first let me explain the physical meaning of these 2 parameters.
So yes, well the phase doesn't mean anything if the phase isn't in real time. So again, we know the speed of light. We know that the phase has to be a component of the speed of light. We know that the wavelength is a real length between events. So why are we talking like it's one big object when we already know clearly in your wave theory that it's a sequence of events that take place at a certain period, using up a certain amount of time.
Parameters of a wave. Consider a very simple example of a tsunami wave.
Right, yes, well, that's not a simple example, a tsunami wave. And obviously it wouldn't have a frequency, now would it? Now, I mean, obviously there's frequencies created by seismic events. So yes, the major tsunami wave is followed by another and another and another, the secondary effects. But clearly you wouldn't say, just looking at one wave coming at you, what its frequency is.
That is going to strike a beach. By definition, amplitude is the maximum displacement of a particle on the medium from its rest position. So if we say that the height of the tsunami when it reaches the beach is about, say, 2 kilometers.
So, and we also know that, look, all of that was quantized in quantum mechanics already. We're pretty, it's pretty rock solid that the energy comes in discrete clumps that are all the same, like electrons. So playing this amplitude game doesn't mean anything. We're not talking about the amplitude. And again, they're only using amplitude because they can use it to simulate the obvious fact that it gets 4 times brighter. When you open the second slit, you got 4 times as much light. That's the difference.
Very much mean that its amplitude is 2 kilometers. Graphically, we describe a sinusoidal wave like this. So the maximum displacement of the wave, of the particles on the wave or the medium, is known as the amplitude A. So this is the amplitude, right? Now let's go to the next parameter, the phase. Phase is defined as a wave's shift from having the maximum level at time t equal to 0. So by how much amount the wave is shifted to have the maximum level at t equal to 0?
Right, and how can it be shifted without a frequency? It has to be compared to something you're shifting. You have to be shifting from some other norm. There has to be a norm to shift from. There has to be some other wave that you're comparing the wave from to say it's out of phase with this wave, the control, the piece. So again, he has 2 waves written on the board to do phase. So again, this cheat is just so obvious. When it's to their advantage, they understand that this is an event that takes place over time. And when it's not to their advantage, they pretend this is one big clump that has this innately built into it somehow. Somehow it has its frequency built into its clump.
Is known as the phase. In fact, the sine and the cosine waves that you are...
I mean, obviously a clump cannot be out of phase. A solid clump that represents the frequency of 500 millimeters or something can't be out of phase. There can't be an element out of phase. There can't be a piece out of phase. I mean, there's just no room for it.
With are just same waves having a phase difference of 90 degrees. They are similar waves, just having a phase difference, that is 90-degree phase difference. Physically, this 90 degrees phase difference means that when one of them is at the maximum, the other one is 0. You can see from...
Right, so I'm just saying that obviously if they converted these into real waves, they would be not making much sense, because they'd clearly be saying Well, no, as you go out of phase, you're changing the frequency. That would be the clear implication. If I take this wave and move it out of phase with the first wave, all I did was just change the frequency. I either made it bigger or I made it smaller. I changed the wavelength.
The cosine and the sine waves. When one of them, that is, suppose they are 90 degrees, pi by 2, sine wave is having its maxima, cos wave has the value of 0. So this is the physical significance of phase. The concept of phase comes into picture when we talk about the sinusoidal waves. It is more relevant in that picture. When we consider light as a wave.
So no evidence that you need any of this sinusoidal stuff. That's all binary. There either is or isn't, the makings of a photon. There either are or not pieces. There's no need for any sinusoidal anything anywhere. You don't have to believe in any of that, and you clearly don't see it in the results. The bars are either photons or not photons. They don't get progressively lighter and darker as their theory would predict. So again, it's kind of obvious it's wrong. It doesn't predict the actual outcome, and it doesn't do it dramatically.
We see that this phenomena has a natural explanation. Waves are the ones that can pass through both the slits, and hence light waves pass through both the slits.
Alright, we know that this diagram doesn't work, so mathematically this will fail completely. So he has this drawn in such a way that these distances are more than he's claiming the distances are. But look how, they do have it quite exaggerated. But it won't get you the right answer. So two sources can't make the pattern unless you make the slits infinitesimally small. That is smaller than a wavelength of whatever you're putting through the slits. And in the case of like light, the average 500 nanometers. I mean, you're talking a 1,000th of a 2,000th of a millimeter. No chance. No chance that you can do that experiment and expect, unless you put insanely bright light going through, to have any pattern at all anyway. But it's clearly not the normal way to do the experiment. It's the abnormal. It's the irregular way to do the experiment, not the regular way to do the experiment. And that's the only way this works. And as I explained, it only works because of a gimmick. Because you're not adding, the second sources are essentially in the same place as the first point sources. You didn't add any distance, so you can't add any interest.
And they interfere with each other. We see a varying pattern of intensity of light on the screen because the waves reach the screen and they superpose. That is, because of the principle of superposition, they show an interference pattern.
So more nonsense. You don't need superposition. There was no superposition in that drawing, right? So again, this is just stuff he's just aggrandizing the story with somehow it's critical to believe that the photons don't know where they are and the pieces don't know where they are and the waves don't know where they are. He just showed you an image. There was no superimposed photons in that image.
Now this was the intuitive understanding of the outcome of this experiment when we consider light as a wave. Let's see what mathematics has.
So of course it's not intuitive, and they're just straw-manning everyone else's rational arguments. So reason is just being straw-manned so they can justify woo. They're comparing woo to crap. And then, well, compared to crap, woo is a lot better. They're not comparing it to a good story.
To tell us. So like I said that we need two parameters to define a wave, the phase and the amplitude. So I consider a sinusoidal wave, Xi1, that is coming from the slit S1, to be a sine of phi. Xi1 can be any parameter. It can be the electric field, it can be the pressure, displacement, magnetic field, anything.
So again, it just didn't make any sense that would mean anything. So he's just really doing frequency divided by distance, or however you want to do it. You can do it lots of different ways. As I pointed out, it's so simple. I mean, the experiment really is so simple when you understand what's going on. So we'll just do one more. I mean, I have to go through it again because people can't follow along at all. I mean, I'm surprised, really. Sorry to say, but some of you people aren't too smart. I mean, you really have to just keep spelling it out. Which is disappointing. So the single slit, here's the simplest math you get. It's just D, right? This is the only distance that matters. You have the wavelength of the light, and you have the distance from the target. You could call that R, right? And that's all there is. Okay, there's your variables. You're done. Okay, you're going to take those variables and you're just going to combine them, and you'll get an answer. But the real answer is, right, all that really happens here is there's a certain number of wavelengths that fit in here. So a certain number of this 500 nanometers, okay, fits in this distance, you know, of either the impediment or the opening. And all you're going to do is essentially, this guarantees there's only a certain number of vectors where there can be a full wavelength of difference between, say if I do this straight line, this would be a full wavelength of difference. This line would be a full wavelength of difference. This line would be a full wavelength of difference. This line could be a full wavelength of difference. And all you're doing is extending that to some new location. So you haven't changed anything. You haven't put it where you can see it. You haven't changed anything. You're just doing exactly the same thing, and all you're going to do is have now longer lines, but the longer lines are going to represent exactly the same thing, and so all you're going to do is take these notches and put them on this longer line. So this line is obviously longer than this radius, and all you're going to do is take the same number of notches and put them on here. And so yeah, they'll look bigger. Same number. Okay, there's nothing, you didn't do anything miraculous. And so in the double slit, as I've pointed out, it's just so obvious what's happening. You need all four sources to see the bright light. That's when it's 4 times brighter. That's when you see it. All right. And if you take away 3 of the sources, there might be still some photons in some locations, but they're much dimmer. The light is much dimmer. So, you know, in the double slit, all you're really going to do is just say, now you have 2 distances. You have the distance between these 2 point sources, and you have the distance between these 2 point sources. Okay, and that accounts for all 4 surfaces. And these 2 surfaces have very few wavelengths, very few notches. So those are going to make a big pattern, big notches on the screen. And then these 2 sources have a lot more, okay, wavelengths will fit in here. So they're going to make little notches compared to these, right? A lot more notches. And so that makes your small pattern, right? And that's going to every location. The small pattern's going everywhere. And all you're saying is where will I see light? Well, you'll see light here because there's 4, 4, 4. You won't see anything here because there's 1 here, but there isn't 1 here, so it's not 4, so no light. Then you'll see light again here. I mean, I shouldn't exit. You'll see light again here. And then you won't see any light here, but it's only 1 source again. No good. Won't work. And then you'll see light here. So only where the 4 sources make a contribution, their 4 sources are in phase, do you have light. But it really has nothing to do with being in phase. It just has to do with what locations will create that wavelength of difference in the path. And that mathematics is strict. And it's going to be completely dependent on these lines are decided at the surface. Okay, so you're done right there. The length of the line is decided at the surface. If I made it all flat, one plane, you could just sort of understand that, you know, I'm really just saying, well, here I have a point. Can you see that? No. Here I have a point in space. Just ignore all that stuff. And I'm just going to compare the distance of another point. So this line is 0. This line is 500 nanometers, you know, of wavelength. Okay. And I'm just saying, okay, there's the difference right there. You know, that's the difference in the path length. And so now they're in phase. Because they're 1 wavelength of difference. So, anyway. All this hype, all this bullshit, and it's just, like I said, you could do the experiment with a piece of string. You just tie a piece of string to the point sources. Tie a piece from the 2 outside sources, tie a piece from the 2 inside surfaces, put a nail in them, and then put notches on the screen, on the rope. It's exactly the same number as the distance. Okay, so the longer string has lots of little notches, the smaller string has big notches, and then you just move the thing in an arc, and wherever all the notches add up, photon. When the notches don't add up, No photon. You're done. It's all this hype, all this bullshit mystery, all this fake story that we have to have a Messiah. There's miracles. We have to explain the miracles. We need the woo physics because only woo physics can explain this insanely unexplainable phenomenon. And it's completely mechanical, completely simple, straight line little vectors. Any idiot can understand that the radius is a smaller line than the circumference of the circle. And so you just multiply this line by whatever, 1.7, and that'll give you this line. That's it.
A is the wave amplitude, like we discussed, and phi is the phase, right? Now consider the wave that is passing through S2 by xi2. A sine of phi plus delta. Now we are considering the waves that are reaching.
So you never have to do any of these, say, sine theta things, these angle changes. The angles are interesting, but they really don't have any. That's one way to see the circular geometry. But I'm just saying it's much simpler just to do the times 1/2 pi thing. You just multiply the distance between the slits times 1/2 of a pi, and it'll tell you how big the notches are.
Particular point on the screen, delta is the phase difference. It arises because waves might travel different.
The notches, by notches I mean the fringes. How big the fringes are, how far apart they are, how big they are. It'll tell you where those nodes belong. They'll tell you how many there are, and obviously by telling you how many, it'll tell you exactly where they are.
Distances to reach a particular point on the screen. So the resultant of these two waves will be xi1 plus xi2. So when you add them, A sine of phi plus A sine of phi plus delta, right? So you take A common, A sine of phi plus sine of phi plus delta.
So you're just saying two angles plus the extra distance, and that's all it is. Blah, 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 blah.
Simple mathematics so far, right? So now, two cases arise. First is that when delta is an even multiple of pi, that is, it can be minus 4 pi, minus 2 pi, 0, 2 pi, 4 pi, and so on. This quantity, sine of...
Alright, so the pi's only become significant because they're using a sign, which is a sign is just telling you a percentage of pi, of a circle, complete circle. So that's why they're using pi. But again, you don't have to do that. You don't have to do the whole circle. All you need to do is know one quadrant, and then you just double it for the other quadrant. So you're just saying, I can figure out what it's going to go this way, and then I just do the same thing I did on this side over on this side, and then if I was to make it a full circle, then I would just flip it onto the other two sides. But I don't have to do any of that. I don't need any of that. So I just use a 1/4 pi. I mean 1/2 pi will get the job done because 2 pi is the whole circle. So I'm just saying 1/2 pi answers the question. The important question. That's where the origin is. You're really comparing two. The sources go in two directions. The lines, the vectors you're going to combine go this way, and then they go that way, right? So they're two different experiments in a sense. The pieces are going left and the pieces are going right, and that the fact that they're going in those two directions means the same distance is going to create both those patterns. The same distance between the point sources. So, but I'm just saying, so if you want to get to the origin, if you want to make your math to the origin, where the variables get their significance from, why the variables are significant, if you want to start at the very beginning, the very basic, the very fundamental place to do the mathematics, you do it recognizing that the number of wavelength distance differences in the distance is causing the pattern, and it's causing it left, and then it causes it right. Or it causes it right and then goes left. I'm just saying that the 2 point sources have two different directions they go to.
Phi plus delta becomes nothing but sine phi. Why is that? Because sine has a period of 2 pi. It means that it repeats its value after 2 pi. So it becomes nothing but sine of phi only. So xi will be, in this case, A sine phi plus sine phi, which will be 2 A sine of phi. Right? And now when we consider the second case, that is,
Right. Now I'm just saying. So obviously I could just rederive that and just put the get rid of the sign and just do a 1/2 pi times the distance d, and I'm done. A would be the distance. All right. So there's nothing more here, I guess. Well, we'll just let him finish.
and delta is an odd multiple of phi minus 3 pi, minus pi, pi, 3 pi, 5 pi, and so on. Xi will become this quantity, sine of phi plus delta.
So these numbers are just basically representing the fact that how many wavelengths fit. So for each wavelength that fits, this is a new number, a new block, a new piece of pattern. But that's it.
Will become minus sine phi. This follows from the basic rules of trigonometry. So xi will be A. This term will remain as such because there is no delta involved in this term, sine phi, minus of sine phi. Because this term will become minus sine phi and hence 0. The intensity is the square of these quantities, and hence we can see that when delta is the even multiple of pi, we are getting a bright fringe on the screen. And when delta is an odd multiple of pi, we are getting no intensity on the screen, a dark fringe.
Right. Well, we know they don't show up that way either, right? We know the dark spots aren't the same size as the light spots. So, in terms of their intensity, obviously their centers are the thing that have the specific distance. So the distance between the center of a dark and the center of a bright is always the same distance. But the brights are obviously bigger than the darks if you look at the pattern. So whatever the phenomenon is, it's not equal. This out of phase thing doesn't have some like, okay, it's 50-50. It's obviously slanted in one direction where you can have a lot of phase irregularity and still have a photon. But again, and none of it obeys any of the sine wave rules. None of it, there's no evidence of any sine wave in the pattern. The pattern is very blocky. Either there are photons or there's no photons. It doesn't go bright in the center and then the band gets darker and darker and darker. That doesn't happen. They look like little bricks of light. So the experiment in photons does not create any gradually on, gradually off pattern. So none of this math actually fits. But I've already made that argument so many times.
This is how we can mathematically, using the simple mathematics, we can explain Young's double-slit experiment, right?
Right. I'm just saying he could have just drawn that as two vectors. You're just drawing the vectors. And obviously you can draw them that way. And then you can draw them that way. So you have to recognize that the vectors you're drawing are going to be in two directions.
So now there was an experiment that could only be explained by Huygens wave theory of light.
Right. So here we go again. It can only be explained by a wave theory of light. No, it doesn't have to be Huygens wave theory, and it certainly doesn't have to be a wave theory. So it just has to be a theory that recognizes this is about frequency. Photons are about frequency. What you get is completely dictated by the frequency, and that frequency, when you're adding things, like when you break pieces off and you're going to reconstruct, clearly the phase would be very important. So clearly a particle model is perfectly consistent with the outcome. It's just that they've decided to pervert it and strawman it because they don't want to believe it.
This particle model lost its security.
Because they like this wooey wave superposition, entanglement to black matter, dark matter, Fig Newton, space, whatever. It's all just a pile of crap.
Later, some of the experiments done by Fresnel and Fraunhofer further demonstrated the wave nature of light. In the year 1860, James Clerk Maxwell, using some...
So that was just a statement out of nowhere saying absolutely nothing about any other proof that was made. There was no other proof. They just refined the mathematics to recognize the fact that, hey, that two-wave thing doesn't work. You need four.
Of the known laws of electricity and magnetism, theoretically calculated the speed of light, 3 into 10 raised to power 8 meters per second. If you want to understand...
he calculated the speed of force, and he already put it in the equation. So again, let's not play any games. He didn't calculate it. He put it overtly in the equation in the form of an electrical constant and a magnetic constant that are derivatives of the speed of light. So it was already in the equation.
physical meaning of the four Maxwell equations, you can watch my video, the link to which is given in the description. So if the particle model...
By knowing the speed of magnetism, they knew the speed of light, is the irony of it, I guess you could say. Or to knowing the speed of the electrical phenomenon, they knew the speed of light.
was dominant in the 17th and the 18th century. Wave model had complete control in the 19th century. However, in the 20th century, a series of experiments reopened the issue, and we again had to resort to the particle model of light in order to explain them. We'll talk about those experiments in the coming video.
Yeah, right. So just absolute nonsense. So again, a physicist saying it's okay, we'll accept this notion that our fundamental diagram of what's happening changes when we do a different experiment. We'll just change the rules. And it'll be a completely different rule and a completely different mechanical process. And that makes sense to them. So they're overtly saying, I'm Christian and Muslim. That's what he's saying. He's saying it's perfectly rational to be both. They're not at all competing theories. They're not completely different. They don't have completely different values. No, same religion. Come on. You know, I probably should use some other more strangled comparison between two very divergent religions, because obviously all of this Middle Eastern religion stuff has a certain common origin. But too stupid. It's both a platypus and an elephant. No, it isn't. Alright, so that's probably enough. So I do have some comments to get to, but they're going to be tedious and irritating. So I'll wait for another video to do that, I suppose. And we'll wait for a day when I don't see anything really profoundly stupid on the internet. I mean, it happens every day. You know, you just run into these videos and you're just like, damn, there they are doing it again. You know, look, they just did it again. And people defend it. You know, I have critics, you know, who make these little snarky comments from their little places, and some asshole was defending the Dr. Becky video. I mean, she clearly doesn't know her physics. She clearly doesn't know the history. I mean, to talk about frickin' electron experiments being done in anywhere in the early 1800s is just insanely stupid. Insanely wrong. You know, really badly wrong. It's like talking about people who are driving cars in 1420 or something. It's just really stupid. Fuck. And a doctor shouldn't be making those kind of mistakes. Fuck. Well, anyway, there's no point. I'm doing this all for the future. No, it doesn't even make any sense. You know, humans are just assholes anyway. The truth isn't going to do them much good because they're idiots. But, you know, the fact is you're going to have to go through this process of recognizing, oh shit, we really fucked up, really bad. It's going to happen. This nonsense is going to, the fact that you have stepped over so many rules of logic to get where you are is going to catch up with you. And you're going to have to accept, oh shit, we were just so full of crap. You know, so sloppy, so lazy, so full of our own little mathematical formulas, our little gimmicks. And you just hid all the gimmicks in mathematics. But all you were doing was stealing and cheating. All the math is a cheat, most of it. Like again, like I pointed out, Einstein's field equations are just an attempt to cheat. They were completely contrived. Einstein didn't write his field equations, you know, when he wrote his theory of relativity. He didn't write the equations that solved the orbit of Mercury beforehand. He had to write them after. He had to add them because it was imposed on him. It was basically said to him, you have to explain Mercury. Okay, if you're going to have a counter theory of gravity, well then explain Mercury. Or you also fail, just like Newton. And yeah, he explained it with a bunch of contrivancy. All right, and he took advantage of the case that Mercury is a special case. It just happens that Mercury is substantially closer to the sun than the other planets. It's not a proportional distance from the sun. Like all the other planets are a much more proportional distance from each other than Mercury. So Mercury is going to be much more affected by any little gimmick I create than any of the other planets because of distance, and I can take advantage of that. And that's all Einstein did. Like I said, right now somebody could write an equation, I'm sure, a really good equation, and it'll just be based on the assumption that the center of the sun's mass precesses a little. Okay, that it moves. That's all it has to do, move a little bit. And it'll affect Mercury, and it won't affect anything else substantially. And that's just the truth. So if I did that, I don't think I'm going to get a New York Times headline saying I'm right. People are just going to say, oh, you just made that up. Well, yeah, so did Einstein just make it up. Yeah. Anyway. Till the next time and such, so forth and whatnot. I can only reason with you. If you're unreasonable, you're unreasonable. This physics is garbage. It's nonsense. The evidence doesn't exist. What they say happens doesn't really happen. It's just really bad physics. Believe it or not.